So I had a chance to watch your video, Five Truths About Earth's Magnetic Reversal. And, I was just wondering, could you possibly take a step back and define what a magnetic reversal, a pole shift is for people that might not know?
Absolutely. And first of all, I want to thank you for putting together um, this really clean and easily consumable web page, magneticreversal.org. It turned out really nice, and you did it on short notice, and I really appreciate that. But in terms of what a magnetic reversal is, it appears that there is a periodic or cyclical event on this planet where the magnetic poles reverse. Just like we have a geographic north and south pole at the top and bottom of the planet, it's the axis around which the planet rotates. Well, very near to that, we have a magnetic north and south pole. You may have heard that there is a magnetic field around the Earth called the magnetosphere. Well, this magnetic field comes out of the Earth at the polar regions, at the magnetic poles, and then wraps around the planet like a cocoon. And every once in a very long time, there's some disagreement on just about how long that is, but every once in a great while, these poles reverse, and this can have significant effects on the planet.
Sure, and you kind of introduced some of those topics in your video, and I was kind of curious. What could those effects be? What would the effect be of a full magnetic reversal on a planet's population? What would happen when this event occurred?
That's definitely the right question. There's two sides to this, and in Five Truths About Earth's Magnetic Reversal, I pretty much was just addressing the facts about it is happening. Here are the observations that we have. There was really no theory involved except for the uh, super flood stuff, which we can talk about again here in a bit. But honestly, there are effects everywhere from the effects on our weather, effects on earthquakes and volcanoes, um, effects on human health, and effects in terms of space weather, the way Earth interacts with the sun, and galactic cosmic rays. Basically energy from space. It affects all of those things in a significant way.
So maybe a good idea would be to just quickly break down each of those effects. So you first mentioned weather. What could happen to the weather that the population observes after a magnetic reversal?
Well, the weather's going to get very serious in terms of climate extreme events. Many people might have noticed that more often than when they were growing up, or more often than they're used to, we have these events where at first we get a couple of days where it is increasingly warmer and warmer, and then it's much warmer than average for that time of year. And then that night they get really severe thunderstorms, and over the next couple of days it continues to just get colder and colder. For example, it is right now the middle of May, and we just had a terrible tornado outbreak start off this month. During this time, it was very warm just to the east of that storm system. When the storm system came through, it was very dangerous, but on the backside of that storm system, on the western side, it dropped 2 feet of snow in the Dakotas, and right now in Pittsburgh, in just over 2 days' time, it went from a high of 92 degrees in some areas to a high just in the 50s. A drop of nearly 40 degrees, and that's a climate extremes event. And the thunderstorms that separated these two were pretty serious, and that's the kind of thing that is going to be happening more and more as we interact more with energy from space. You know, on this planet, every low pressure system sucks in, and every high pressure system in the atmosphere pushes outward. And in the northern hemisphere, all the low pressure systems do this counterclockwise if you're looking from above in terms of the low pressure sucking in. And in the southern hemisphere, all the low pressure systems suck in sort of a clockwise pattern. But those things would reverse uh, after a magnetic pole shift, just like if you flush a toilet in the northern hemisphere versus the southern hemisphere, it's going to it's going to spin. The water is going to spin down the opposite way. All of these things are going to change because of Earth's magnetic field reversing, and so that'll, for a brief period of time, will leave you with some very powerful windstorms once it happens. And as we're on our way to it, the kind of extreme climate events back and forth in terms of the weather we're experiencing are just going to get more and more numerous and extreme.
Yeah, and I'll tell you what, living in Pittsburgh as well, I've definitely noticed just the climate extremes and the swinging from extremely hot to extremely cold, um, and that's been going on for a couple years now, and that's just kind of very interesting to observe. And to your second point earlier, earthquakes and volcanoes. So I'm kind of interested to hear your thoughts on how a magnetic reversal would affect those geological events.
Well, absolutely. Um, the same way I talked about how the storms will be getting worse even before the magnetic reversal happens. That will be due to the increasing space weather energy effect on the planet. When I talked about the low pressure system's spin changing direction after the reversal, that's because Earth's magnetic field has changed. But as the field is weakening on the way to the reversal, both the sun and galactic cosmic rays are going to be able to have a lot stronger effect on our weather, and that's going to be the cause of that. Now, I bring that up again now because that's the same kind of thing that we're looking at in terms of our earthquake triggers. Um, we have done a number of studies on how the solar polar magnetic fields, things like coronal hole activity, coronal mass ejection, solar flare activity, uh, certain things in the solar wind, galactic cosmic rays, a number of elements of space weather uh, can be highly correlated in a dependence form to these large earthquake and volcano events. It's one of the things we've been looking at big time over the last few years, and so the only thing that's really modulating that interaction is Earth's magnetic field. And so as that gets weaker, the energy from space will just interact with Earth more and more and more, not just in the atmosphere, but through the lithosphere, the crust as well. And that's where you're going to get the more severe and more frequent large earthquakes and volcano eruptions.
So it seems like lots of extremes and lots of just very cold, very hot, very intense geological activity um, in in regards to the weather and geological activity. But what about people? What about the population? What is going to happen to an individual or a community? Human health effects, that kind of stuff, during and after a magnetic pole reversal.
Yeah, absolutely. Well, it's it's very difficult to say what would happen afterwards. That would be different than what would be happening on the lead up to the reversal itself. There is some speculation that after the magnetic reversal, human memory may actually be affected, or other things of that nature. But other than that, really, all the human health effects are things that you're also going to start to see on the lead up to it because it's really that weakening magnetic field. I call it the magnetic shield because that's really what it is. It's what protects this planet from dangerous energy from space. And
That's really interesting that you brought up memory. I just kind of had this thought. So our bodies are, excuse me, our bodies are built upon, uh, you know, electrical discharges in the brain. They're built on iron in the blood and other magnetic materials, and other electrical qualities to our bodies. So it is very interesting to think about. If we were to switch the magnetic poles, how would that affect even just the basic compositional elements of your body?
Yeah, absolutely. Now, the one argument against that is you can fly down to the southern hemisphere where the other pole is right now, and you'll be just fine. And people in the south can come up here. Now, um, one could make arguments around that. Uh, the real non-speculative aspect, the real thing that even no official group, not NASA, not the ESA, none of the groups that you would expect to be studying this thing, ignores or denies this risk, and that is the risk of this space energy to do damage to plants and animals in terms of causing cancer. And not just in terms of the ultraviolet rays, but in extreme solar flare events, the X-ray radiation as well, the extreme ultraviolet radiation, the microwaves that the sun produces, um, and perhaps even the radio output of the sun. All of these things are going to have basically an open door to Earth when the magnetic field starts to fade. And the first thing that comes to mind is cancer, but you know, there are a lot of other things that can result even just from the mildest immunodeficiencies that one could get from that increase in radiation. Um, and just to give an example, there was a minor solar space radiation storm caused by the sun here at Earth back in 2013. And based on the analysis from the US government with the help of NASA and a couple other groups, they determined that from this minor event, it was likely that 4 to 6 people were exposed to dangerous levels of radiation enough to the point where they could contract fatal cancer in their lifetime. Now, this was a very minor storm, and it only included high latitude flights because these are most dangerous at the poles. But for example, if this had been the most severe kind of storm that we know of, that number could have been in the hundreds or thousands, and that's talking about a magnetic field that is strong. They really didn't even factor in the fact that the magnetic field is weakening. When you consider the fact that our protection from the space energy is dropping, and it's dropping all over the planet, and so we're expanding the area that's dangerous as well. The same kind of events today could be endangering thousands to tens of thousands of people, and the really severe events today put every single flyer in danger. It puts people on the ground at high latitude in danger, and depending on how weak the magnetic field gets, it might put everyone in danger at that time. It certainly puts everyone at the International Space Station and at Tiangong 1 in danger if we lose the magnetic shield in that way. And so, keeping in mind that there are a number of ways that you can become sick from radiation other than cancer, that's the main thing that you think about in terms of human health.
So we are aware of the concerns with the magnetic reversal, and is there anything in your research or in other people's research that you've looked into? Is there anything that the Earth's population can do to prepare? Not saying it's going to happen or when it's going to happen, but just to kind of be prepared and mindful of the fact that this is happening. Do you have any suggestions on how the population can better prepare themselves for a magnetic reversal if it occurred?
Well, there's only so much you can do for something like this, and you know, if the magnetic poles, as you may have seen in that video, Five Truths About Earth's Magnetic Reversal, if the magnetic poles do come together around the bend of Indonesia, and the other one pops out somewhere near Brazil, and they don't end up where they were, things could get even worse on the planet. Uh, and even if things don't get worse, how do you really prepare for? How do you prepare for it if you know your town is slated to get a big tornado come through and then a massive snowstorm a day later. How do you prepare for it if a major earthquake or volcano is going to, uh, happen near you? Uh, and, you know, on top of all of that, one of the main things, the major natural disaster, the one that really trumps them all, is the one that has never really afflicted humans yet. We've never seen it, but it's the greatest natural disaster, barring an extinction level event, that could happen. And indeed, it might end up being something close to an extinction level event. And that is a solar induced global EMP. The sun has the power uh, to create an electromagnetic pulse far greater than any weapon humans have. Um, the explosions that we see regularly on the sun, the explosions themselves are bigger than Earth, and the plasma clouds they create within hours of the eruption could hold hundreds to thousands of suns inside themselves. The energy associated with these things are tremendous. Now, normally our magnetic shield is strong enough to deflect these no problem. It would take something very, very powerful in order to overcome that and really do damage to the global power grid. But if it were to happen, and especially if it were to happen when our magnetic field was weaker, it is truly the kind of thing that could send Earth back to the Stone Age. There was a comment by a number of NASA scientists, and many scientists have commented on this, that if a Carrington event, which was the great super solar flare of 1859, if that happened again today, that it could cost up to $2 trillion and take 10 years to repair Earth's power grids. Well, it may cost much more than that if the field is weaker and we do lose the global power grid, because everything you would used to rebuild the power grid requires electricity in the first place. So you're kind of stuck in a loop there where you're back in something that sort of resembles the Stone Age.
Mm-hmm.
At which point, much of the things you've been using to prepare, have to come into question. You have to adapt. And, it's the kind of thing where when our magnetic field is really strong, we were taking, X10 solar flares, X12 solar flares. An X5 solar flare produced a geomagnetic storm, but it wasn't anything to worry about. We're at the point now where if we got an X20 solar flare directly in Earth's direction, I would be fairly concerned. If we lose another 20 to 30% of Earth's magnetic protection from this space energy, it may take very, very little from the sun in order to cause this global blackout. In fact, it could be the very first thing we see before the weather gets bad and the earthquakes and the volcanoes. Wouldn't that be a terrible thing if the world got sent back to the Stone Age and then all of those terrible things started happening?
And one last question. Why make this website?
Well, the impetus to create this free resource and others was really the fact that I believe this is one of the most serious issues facing us today and in the imminent future. This is not something for our children or our grandchildren. This is something that most people listening to this are going to be dealing with in their lifetimes. This is the kind of thing that was really, really a scary thing for society when they were not dependent on electricity and were able to deal with adversity out in the natural world and survive. So, um, I wanted to reduce everything to something that was clean, clear cut, um, easy to understand, uh, fully cited so you guys could learn more, dive down your own little rabbit holes if you wanted to. But basically, just something that you can share with someone else that they're going to understand. Um, some of these things are very difficult to communicate, and when we try to communicate them to other people, sometimes we get tongue tied, we forget important things. I wanted to make something quick, clean, and completely inclusive that we could share amongst people that we wanted to inform about this significant Earth change, and we knew that this would be something that would be easily understood and that would give a complete picture of exactly what's happening right now on the planet.